Hi everyone, my name is Aditya Deepak Satpute. I am from Guru Gobind Singh Polytechnic third year electrical. So today we will discuss about the types of protection for busbar and transmission line. Name of subject is switchgear and protection. And my group members are Gaurav Vilas Kulkarni, Pratham Sunil Kaire and Jay Sanjay Bhavishkar.
Introduction. Busbars and transmission lines are important elements of electrical power system and require the immediate attention of protection engineers for safeguards against the possible faults occurring on them. The modifications are necessary to cope with the protection problems arising out of greater length of line, a large number of circuits connected to a busbar. Fortunately, less expensive methods are available which are reasonably effective in providing protection for the busbar and line. Faults of transmission line. Faults occurring on transmission lines are given below. Transmission lines are of much bigger lengths, hundreds of kilometers, and these are exposed to atmosphere. So there are chances of faults occurring due to wind, storms, ice, flashovers, lightning, falling trees, objects, birds, dirt, dust disposition, etc. So the faults may be short circuit fault, open circuit fault, earth fault, or lightning fault. Short circuit faults include line to ground fault, line to line fault, double line to ground fault, and three phase short circuit faults. Open circuit faults occur when line breaks and connection is broken. Protection of transmission lines. As the length of electrical power transmission line is generally long enough and it runs through open atmosphere, the probability of occurring fault in electrical power transmission line is a much higher than that of electrical power transformers and alternators.
Requirements of transmission line protection. Fault on the transmission line should be detected as fast as possible to maintain the system stability. Since the transmission line is having thousands of kilometer length, the protection system should be capable of identifying the location fault. In the event of short circuit, the circuit breaker closest to the fault should open, all the other circuit breakers remaining in a closed position. In case the nearest breaker to the fault fails to open, backup protection should be provided by the adjacent circuit breakers. The relay operating time should be just as short as possible in order to preserve system stability without unnecessary tripping of circuit. The common method of transmission line protection are given below. First is time graded over current protection. Second is differential protection, and third is distance protection. Time graded over current protection. In the scheme of overcurrent protection, time discrimination is incorporated. In other words, the time setting of relays is so graded that is, in the event of fault, the smallest possible part of the system is isolated by operating the relay nearer to the fault location. Next is differential protection. The differential pilot wire protection is based on the principle that under normal conditions, the current entering one end of a line uh, leaving the other end. As soon as a fault occurs between the two, this condition no longer holds, and difference of incoming and outgoing current is arranged to flow through a relay, which operates the circuit breaker to isolate the faulty line. Next, distance protection. Distance protection is non-unit system of protection which measures the impedance between the relay location and the point where the fault is incident and compares it with the set value. If the measured impedance is less than the set value, the relay operates and isolates the faulty section. Since the line impedance is directly proportional to line, we get the exact location of the fault in kilometers. Since it protects a certain length of transmission line, it is called as a disk relay.
Abnormalities and faults in busbar. As we know, busbar have numbers of inputs and number of outputs connected to it. Therefore, fault level at busbar is very high. Therefore, two types of faults that mainly occurs on busbar. For example, single line to ground faults and face-to-face fault. There are two types. Out of the single line ground faults is frequent that phase is face to face fault, but the face to face fault can occur from medium to high voltage buses. The causes of busbar fault can be the failure of support insulator resulting in earth fault. Second one is flashover due to heavily polluted insulator. Third one is the flashover across the support insulator during the overvoltage. Fourth, failure can connected equipment. Fifth is earthquake mechanical damage, etc.
Busbar protection. In this slide, the busbar zone for the purpose of protection include not only the busbar themselves but also the isolating switches as well as circuit breakers and the associated connection. When in the event of fault of any section of the busbar, all the circuit equipments connected to that section must be tripped out to give complete isolation. The standard of construction for busbars has been very high, with the result that bus faults are extremely rare. However, the possibility of damage and service interruption from even a rare bus fault is so great that more attention is now given to the form of protection. Improved methods has been developed, reducing the possibility of incorrect operation. The two most commonly used schemes for busbar protection are first one is differential protection and second is fault bus protection. Differential protection. The differential protection is the method of busbar protection differential schemes in which current entering as well as bus are totalized. Second point is that during normal load condition, the sum of the current is equal to zero. When the fault occurs, the fault current upsets the balance and produces a differential current to operate a relay. Fault bus protection. It is possible to design a station so that the faults that develop are most earthly faults. This can be achieved by providing earth metal barrier known as fault bus surrounding each conductor throughout its entire length in the bus structure. With this arrangement, every fault that might occur must involve a connection between a conductor and an earth metal part. By directing the flow of earth fault current, it is possible to detect the fault and determine their location. This type of protection is also known as fault bus protection. Thank you for listening.